Hello everyone, today I wanted to share a PCB project that I've been working on for some time now. It's called ToqueCAN. It's a Raspberry Pi Toque, technically not a hat because it doesn't have the E2 Pro, which is useless to us Clipper users anyway. So it's a Raspberry Pi Toque with two CAN bus connectors here, and there is an expansion connector here for even more. Of course, it's called more CAN. This also generates the 5 volts for the Raspberry Pi, so you just connect this to 24 volts power here through the screw terminal. It powers the Raspberry Pi and obviously the CAN bus connectors here. This also has a 3-port USB hub here, and it also has NeoPixel control and fan control. So if you have a 3-pin PWM fan you want to use with this, you can also control its speed through this, and yeah, adjust that based on the temperature from the Raspberry Pi. So there is a mount for mounting that fan here as well. This has been in the works for some time now. The initial work for this started last summer, and it's been in active development since December, after I started spending more time on this after someone requested basically this thing. But yeah, I'm pretty happy with how this turned out, and this is now also published on GitHub as usual. But before I talk more about that, let's take a closer look at the PCB and its features. And starting with the CAN bus, as you can see, this has two 2x2 microfit connectors here. So these are 2x2. They not only provide the CAN bus communication, they also provide the power for the CAN bus devices you have connected to these. And the power is coming from the screw terminal here, which is designed to be connected to 24 volts power. And that is also obviously powering the 5 volt buck converter. It is 10 amp fused here. The buck converter and some safety margin can be up to 2 amps, so up to 8 amps is available through these connectors here. Or if you want to spread the load equally, then 4 amps each, which should be plenty enough for almost every CAN device you might have connected there. Maybe with the exception of if you want to connect like a bed heater or something, then maybe it's not enough, but hot end heaters and stuff like that, that is more than enough for powering all that. So yeah, any CAN device you want to connect there on a 3D printer, with the exception of potentially bed heaters, it should be fine through those connectors here. And the fuse I use is by Little Fuse. It's a reputable fuse manufacturer, so it's not like those Amazon or AliExpress special fuses where they may or may not blow. This is a fast blow 10 amp fuse by Little Fuse. Now if you want to connect one CAN device to these CAN connectors, then you populate this jumper here for the CAN termination resistor. If you want to connect two CAN devices, then you don't populate this jumper here for the 120 ohm termination resistor, and obviously you have the 120 ohm termination resistors on your CAN devices. Most CAN devices have jumpers for the termination resistors, so you just populate the termination resistor jumper on your CAN device. You'll notice that the more CAN connector here also has two jumpers populated. This is how it's normally meant to be used when you just have two CAN devices connected here. But if you want to connect even more, then instead of populating this connector with jumpers, you connect the JST-XH connector here to an external PCB, and that I will talk more about later in the video. But yeah, if you're just connecting two CAN devices, then you just populate these jumpers, and they work just fine. And they are just standard pinheader jumpers, by the way, none of that special sized jumper stuff here, just the standard jumpers that you probably have lying around. But if you buy from me, for example, because I can't speak for other vendors, but if you buy from me, I will include jumpers with your purchase, of course. All that CAN stuff is connected to this TI CAN transceiver here, and this CAN transceiver, in my experience, works really well with Clipper with 1 meg CAN bus. So yeah, it works really well. And this CAN transceiver is connected to this STM32F072 MCU. On this MCU you can run Clipper in bridge mode or Candlelight, whatever you prefer. But I actually recommend Clipper in bridge mode, not Candlelight. I had some problems with Clipper in bridge mode in the past on other PCBs, but on this PCB, which is the PCB I'm using on my Voron 2, and I've also tested 40 of these PCBs, I've never ran into any issues with Clipper in bridge mode running on this MCU, so I do recommend Clipper in bridge mode. But Candlelight is, as I said, supported too. But if you use Candlelight, some of the features of this PCB, none of the stuff that's really important, but some features are not available with that, and I'll talk more about that in a sec. But yeah, if you prefer it, you can run Candlelight as well. And this MCU obviously needs a USB connection, so it is connected to this chip here, and this chip is actually a 4-port, not 3-port, 4-port USB hub. 3 are going to these USB connectors, and 1 is going to this MCU. And this input for that is this USB connector here. So to use CAN bus, you do need USB connection to your Raspberry Pi. You can get some CAN transceivers working through the GPIO pins. There are some CAN hats available on Amazon and AliExpress and places like that. But if you've read other people's experiences with those CAN hats, you know that the GPIO pin CAN hats don't really work that well with Clipper. So you do need a USB connection, but since this is designed for 3D printers with small electronics chambers, I wanted to make sure that this takes up as little space as possible. So say this is your Raspberry Pi in your electronics chamber, you can use this 180-degree USB adapter thingy I designed, and as you can see, it barely sticks out from the side, and yeah, that way it doesn't really take up much space, and you just route the USB cable between the two PCBs, route it through these between these USB stacks here. If you have a Raspberry Pi 4 like this one, if you have Raspberry Pi 3 or 5, then this one will be Ethernet, so between the Ethernet and USB in that case, and just connect that to a USB connector here. And if you don't want to use this, that is also fine. It will work just fine. You just disconnect that. Let me pull this a little further. There we go. You can just connect a USB cable here, and if you use a 90-degree one like this one, it will still not stick out all that much. But if you want it to be as compact as possible, you need a 180-degree adapter like this, and I will include one with each purchase in the box. But again, I can't really speak for other vendors, of course. But yeah, you need a USB connection is the most important point there, I guess. But it's not a big, I don't think it's a big deal in my opinion. Anyway, moving on. As I said, this has a 5-volt buck converter, and that supplies up to 5 amps of power, which is going to the USB connectors, the fan, the NeoPixel header, the 3.3 volt logic on here, and primarily, of course, powering the Raspberry Pi, and the power to that is traveling through these GPIO pins here. And 5 amps is plenty of power for all that. I've never ran into any issues with this on my Voron 2, and I don't expect to. I've run a fairly heavy test scenario with that 5-volt 5 amp buck converter. I haven't had any heat issues or power issues or none of that. So I had several USB devices connected, was running a stress test on the CPU of the Raspberry Pi, and I had an LCD connected and NeoPixels connected and fan connected, and yeah, maxing out all of this as much as possible and no issues whatsoever. But yeah, speaking of the fan, which I briefly mentioned there, the fan, as you've seen earlier in the video, there's a fan cutout here for you to mount the fan, and yeah, you do need a 3D printed part for that, which is this thing for 30mm fans. 40mm fans are also supported, so instead of having this piece on the back side, you just have this in the front. You screw through the PCB and mount the 40mm fan to this. So if you have a 40mm fan lying around but not a 30mm fan lying around, you can use 40mm as well. And for the power for the fan, 5 volts and 24 volts are both supported with this jumper here, which I did my best labeling all the pins on the back side here. So this is the fan voltage. You can pick 5 volts, which is obviously coming from the buck converter, or 24 volts. Obviously ground is ground, but you'll notice there is a third pin, that is the PWM, and that also has its own jumper here. That is one of the things I was talking about when I said you probably want Clipper in bridge mode running on this. If you're using Clipper in bridge mode, you obviously have access to this MCU's pins in Clipper, and that means you can do your fan speed control using Clipper. So if you want that, then you populate the jumper for the MCU here, and then there is a sample config which is on the GitHub repository of this project. You can just use that and tweak if you tweak the temperature and whatever if you need to tweak it, and yeah, just control the fan using Clipper. And if you don't want to do that, if you want to use candlelight here, you can still speed control the fan, but then in that case you populate the jumper for the Raspberry Pi here, and the PWM data for the fan comes from this pin on the Raspberry Pi. And yes, I said PWM, so if you want to speed control the fan, you need a PWM capable fan. That's what I'm using here, this QE devices, whatever this part number is. I bought this on Mouser, which I'll link it in the description below so you can buy it from them directly, and it's been working pretty well. I think there is a fan that should work on Amazon as well. I'll link that in the description below as well, but yeah, this is something that's not included in the box and I don't sell currently, but do let me know if you are interested in buying the fan from me as well. If you don't have a PWM capable 30mm or 40mm fan, you can just use a normal 30 or 40mm fan, and you won't have speed control obviously, but these 30mm fans tend to be very quiet anyway. And then finally there's also a NeoPixel connector here. This only works with Clipper and bridge mode, so it is connected to the MCU. There's no jumper for this. But if you want to control NeoPixels, that is also available on here. This is designed for Vorons, obviously, and no Voron PCB is complete without a NeoPixel header. So there it is. If you want to connect NeoPixels, if your name is Timid, then that is also available on here, of course. Obviously, this doesn't block the GPIO pins coming from the Raspberry Pi. As you can see, these are the long-legged female, yes, I'm 12, variety. So you can easily just connect DuPont cables here and use the pins coming from the Raspberry Pi. None of the logic GPIO pins are used with this PCB, with the exception of the PWM signal for the fan, if you use that instead of using the signal from the MCU with Clipper and bridge mode. So yeah, all of the GPIO pins from the Raspberry Pi are still available through this connector. So yeah, guess that's pretty much it. The USB connectors are all ESD protected. So again, this PCB, because it's kind of an expensive PCB, I tried to make sure that this has all the protection features built in, so they're all ESD protected. As I said, the power input is fused, and there's also a reverse polarity diode there as well, just in case. Yeah, did my best with the silk screen, as I said, so everything is labeled as well as I could. There is these 3 pads for USB. So as I said, you do need a USB connection, but these pads could help you do that as well if you don't want anything sticking out the side of the printer at all. And I will talk more about the history of these pads in a bit, but that is something I experimented with, and I ended up using this 180-degree adapter anyway. But these are available here if you want to come up with your own custom solution. So yeah, those are there. And finally, I also want to say thanks to Leon for creating this logo for the ToqueCAN. I don't know how well you can see that on the silk screen, so I'll just show it on the box. It's ToqueCAN, obviously, wearing a toque. I think that's a pretty cool logo. So I'm probably the least talented person when it comes to stuff like this. I mean, my channel logo, which admittedly is nothing special, even that I had to pay some guy on Fiverr to create. So yeah, huge thanks to Leon for creating this logo. I think it looks pretty cool. So yeah, that's the features of this PCB. So here is my test platform for testing the ToqueCANs I've tested so far. I think I've tested 6 ToqueCANs on this so far. I also have a test bench where I just plugged in a bunch of CAN devices and whatnot, and with that I tested 40 something ToqueCANs, and every single one passed. But that is not a real life test. It doesn't last for many hours, so this is the real life use case test, and it's been working pretty well here too. I've been printing with this printer pretty much non-stop for ever since I released the last Voron 2 video, which was I think it was like 6 weeks ago, something like that. I've been printing pretty much non-stop since then, with the exception of last weekend where I was at Remurf. Yeah, it's been going pretty well. So for those of you who are not familiar with my Voron 2, this is an official Raspberry Pi display directly connected to the Raspberry Pi, and it's also being powered by the Raspberry Pi, and the Raspberry Pi is mounted right behind it. If we move here, probably you can't see the Raspberry Pi, but you can probably see its heatsink, the copper heatsink I have on top of it, and the LEDs on it. And on top of that, obviously, is the ToqueCAN. So yeah, that's where it's mounted. I'm using the 180-degree USB adapter thing there too. It's reversed in terms of how I plugged it in, simply because again I wanted to test multiple ToqueCANs, and that made that a bit easier. But yeah, there is a ToqueCAN there. I'm using its USB connectors too, so 2 of them are used for the Nevermore filter, which is currently turned off because I need to update the firmware, and the Isik Spider, which is controlling my Z motors and 2 of my gantry motors. I have 4 motors on the gantry. The other USB port I also tested with a CUSPA, and the 2 CAN bus devices are connected to those connectors as well, and those are going to the CAN bus PCBs here. One of them is the Big Tree Tech EBB SP2240 PCB that's in the toolhead, and the other one is back there. That's GBB15. It has 2 TMC2209 drivers and an MCU, obviously, for the gantry motors, and the other 2 are, as I said, connected to the Isik Spider. If you want more information about the reason for that setup, just watch my last Voron 2 video. So yeah, let's move on to the documentation of this project and its GitHub repository. So with this project, because it is a fairly complicated PCB with many features, I wanted to make a proper manual for it. So that's what you're looking at here. It's 21 pages long, so it is pretty detailed. But here we can find a list of its features, the extra parts you might need, which by the way, most of them are included with your purchase if you buy it from me, but you might need, for example, the fan or things like that, or like a USB cable, but vast majority of the stuff like the JST-XH connectors, microfit connectors, etc. I will of course include those. And yeah, just guide for assembling it. For example, the step 1 here I also do, because I also test every single PCB I sell. But yeah, if you buy from a different vendor and that vendor doesn't solder the GPIO pins, then that's the first step. And then the fan mounting, both 30mm and 40mm, and then mounting it on wherever you are mounting it, and then putting the ToqueCAN on top, etc. All the jumper settings here, the connectors powering the ToqueCAN, the 2 firmware options, candlelight or clipper and bridge mode. And as I said, I like clipper and bridge mode simply because it has more features. Like I'd prefer to control the speed of the fan, for example, using clipper instead of using the Raspberry Pi's built-in utility, but you can do that too. And yeah, CAN bus instructions, you can probably find this stuff on Clipper's website as well, but this is for example, these are the settings I recommend for the CAN 0 in the interfaces directory and stuff like that. Raspberry Pi's PWM fan control if you want to use that, or if you're using clipper and bridge mode. Then instructions for finding the config, which is on the GitHub repository. I also explained the MoreCAN connector in detail as well, but the MoreCAN connector, it's essentially like this is where the CAN transceiver is coming, and you also have the 120 ohm termination jumper. One of the CAN connectors is directly connected to the CAN transceiver. The other one goes through the MoreCAN connector, and it's essentially so that you can add even more CAN devices. So how that would work is it would run from the CAN from here to the CAN device, maybe to another CAN device, and then back into the MoreCAN connector. And that's why if you're not adding extra CAN devices, you populate it with the jumpers so that the traces are connected, so you can use both CAN connectors on the PCB. But if you want to add more CAN devices, that is also supported, and I'm pretty sure there is a PCB out there that can accommodate this, but I might make my own as well if there is demand, if you need more than 2 CAN devices. But for most people, I guess 2 is probably enough, but again, if you need more, there is a connector for that too. Goes into chips and their specs, debugging instructions, and for example, the SWD IO pins and stuff like that. The schematic, which you can also find the actual schematic, which is an easy EDA file on the GitHub repository, and even more resources down here. So it's a pretty detailed manual. I wanted to, as I said, this is a pretty complicated PCB, and I wanted to make this as easy for you to use as possible. With things like the CUSPA, for example, you don't really need this much detail, but since this has a lot of features built in, I wanted to make this as detailed as possible, I guess. And yeah, this is available on the GitHub repository, which is here. So it's linked in the description below as well. On the GitHub repository, you can find the purchase links. You can find the instructions here. This will go to the manual. You can find the Gerbers here, or the 3D models, or the STLs to download for fan mounts or CAD files, which includes a model of the PCB as well, and the source as well, which is an easy EDA source, but that's what I use for designing PCBs, so that's on here as well. And yeah, I mean, it's of course GPL v3 license as usual, and if you want to directly purchase from me, that's also linked in the description below and the GitHub repository, and it's available on my store. I am in the US, and this should qualify for free shipping in the US, since I do free shipping over $50. I do ship internationally as well, with the exception of the United Kingdom, which I'd love to ship to, but UK has some weird VAT laws that I just can't ship to the UK. I wish I could. But let's move on to the history of this project, and then we'll end the video after that. So in these videos, I also like to talk about the development history of the project, the inspiration for it, how it was tested, stuff like that. And for that, we have to start by talking about PiCAN, which is something I released last summer. It's a tiny USB drive sized, and there's actually even a 3D printed case for this that makes it look like a USB drive. It's a tiny USB drive sized and shaped USB to CAN bus adapter. As I said, this was released sometime last summer. While this was in development, it was originally called USB CAN. I tend to have different names for projects while they're in development. For example, the ToqueCAN was called PiCAN, because I did just T to the end, but yeah, this was called USB CAN, and I was trying to come up with a different name for this, something that's a bit nicer, I guess. And for a brief period, I was considering naming this ToqueCAN, the bird, but I ended up calling it PiCAN because you plug this into Raspberry Pi. Plus, the 3D printed case is the shell, so I sell them in shell too. But anyway, yeah, it started with this because after naming this PiCAN, I started thinking to myself, if this is called PiCAN, it really needs to be at least specific to a Raspberry Pi. So in the Raspberry Pi world, that means it needs to be a Raspberry Pi hat. So I had this idea of having a Raspberry Pi Zero sized hat. It had one CAN bus connector on it, and it had the same STM MCU and all that as well, and was connected with USB cable because, as I said, CAN bus over GPIO pins don't really work that well. But it was Pi Zero sized instead of a Pi, full Pi sized. It had the USB hub on it as well, but I actually hadn't really designed that much. Just had like a very early schematic for that. I added Max31 865s to that as well, and they were connected to the GPIO pins, because at the time I was thinking of running Candlelight on the MCU, not the Clipper in bridge mode, since I had problems with that in the past. But as I said, that works well with the ToqueCAN. And yeah, I also had a brief stretch goal in mind of adding the 5-volt buck converter too and all that. So essentially just a ToqueCAN with one USB connector instead of two and no fan cutout. But I ended up scrapping that idea because, yeah, I mean, not many people need Max31 865s, for example, and I also just released a CAN bus thing at that time, and I just sort of, I didn't really cancel it, I guess, but I stopped working on it. I have a bunch of projects like that I just stopped working on. But fast forward to December 2023, someone mentioned that they were looking for a PCB like this for a printer that I'm not going to talk about. It pretty much was the same feature set with the exception of the fan cutout, which I've added, and I also added a bunch of other features as well. So most of the development of this happened in early to mid-December, and I ordered prototypes back then, which is this thing. So this is V1.0, this is the prototype, and I think I got these either in late December or at the latest early January. So I had these prototypes for some time now, and fortunately the first prototype actually worked just fine. So if you look at release PCB V1.0, like there aren't many differences. It is pretty much the same PCB. I also had a beta tester for this, and I haven't heard any complaints from him either. So again, it worked just fine right from the beginning. The reason for the delay, the reason it took me this long, isn't the main PCB. It's to do with these pads, as I think briefly mentioned. So one of the goals with this was to make this as compact as possible and not have anything sticking out the side of the PCB, because when you put this on the Raspberry Pi like so, if you have a USB cable sticking out, that takes up a lot of space. And as I said, this is designed for 3D printers with small electronics chambers, so that wasn't ideal. So I designed these pads on the back, and the goal with those was to use a ribbon cable like this one, and solder the ribbon cable there, and once seated on Raspberry Pi, just connect the USB cable like so. And of course they didn't work, as you might expect, since, as I said, they delayed the PCB by quite a bit. I got the prototypes back in, I think it was January. So yeah, the problem with that flat flex ribbon PCB idea was it initially seemed to work, and I even ordered a second prototype, which I ordered because I think that looks a bit nicer than black ones, but black ones ended up being even worse. The thing was, there were some intermittent communication issues here and there, and yeah, I think it has to do with how those flat flex PCBs are designed. The traces aren't on the same layer, and since there are only two layers, the data traces aren't also shielded, unlike you would have in a USB cable. So I think that was the problem with those. But with the 180-degree USB adapter thing on the side, I think this setup is still very compact, and that works pretty well. Like, no problems with that at all. As I said, I've been testing that on my Voron 2 for quite some time now, and I also tested every single PCB I have on a test bench too, and yeah, no issues. So these flat flex PCBs were the cause of the delay. I think you should still be able to use those pads by soldering USB cables there directly if you want it even more compact. But as I said, I think with that 180-degree USB adapter thing, I think it's still a pretty compact setup. And if you don't really care about that, you can just plug in a USB cable on the side as well. That will work just fine too, of course. So yeah, I guess you have a few options for how you want to connect it. What I personally am using, as I showed on my Voron 2, is that 180-degree USB adapter and a short USB cable going to the Raspberry Pi. So that's the ToqueCAN. As I said, this project is an open source project, so there is a link to the GitHub repository of this in the description below. If you'd like to purchase one, there is a link to my store, which is also linked in the description below. If you'd like to purchase from a different vendor, which I'm sure there will be more, I don't know, at the time of recording this there aren't, but I know for a fact there will be more. They will be linked in the GitHub repository, which is linked in the description below, as I said. This project is, as I said, open sourced under a GPL v3 license, which means vendors are allowed to sell this without paying me a cent. So if you like to purchase this from a different vendor, I would appreciate the support, whether it's a GitHub sponsorship, Patreon membership, or YouTube channel membership. They're all linked in the description below. I've benefited a lot from the open source projects I've used in the past, like Voron, Clipper, etc. So I'd like to do my best to contribute to these open source projects, but you know, PCBs like this take a lot of time and money to develop. Yeah, anyway, they're all linked in the description below, and I hope you found this project interesting. If you did, please leave a like down below, and stay tuned because I have even more open source PCB projects in the works. So that's it for this video, and thanks for watching.